Here we're going to do part C of your assessment practice here on basic geometry shapes. Part C asks us to draw triangles from coordinates B, with coordinates B, A, B, and coordinate C, C, D, and coordinate A is 0, 5. We have to find the midpoints, formulas. We also have to investigate the quadrilaterals formed by joining 4 points. So here we've got our triangle. We plot in the midpoints. The midpoint for AB is you add your x values and halve them, and then you add your y values and halve them, and just leave it as formulas like that. Midpoint for BC, the same sort of thing. Add your x values and halve them, y values, and the same for midpoint of AC. And so there are your midpoint formulas. That should pose no problem. Now we have to join 4 points. I'm going to join P, B, Q, R, and that forms a quadrilateral because we're asked to investigate the properties of quadrilaterals formed by joining 4 points. I could have done PQ AR, I could have done PQ AC, I could have done BQ RA. Some of those would form trapezium shapes, or looks like trapeziums. We'd have to prove it, but these ones here form quadrilaterals that look like parallelograms. So is it a parallelogram? We're going to investigate the properties. We could check for the gradients, but I'm going to use the sides this time. Are the sides equal lengths? Doing the gradients to make sure that they're parallel could have been good enough, and that would prove it's a quadrilateral. So here we have the distance formula. We subtract our x values and halve them. We're finding the distance from P to B. We square them, then subtract your y values, square them. Now when you do this, notice that 1a minus a half a is half a all squared, which is a quarter a squared. And for the second bracket you've got 1b minus a half b, and that gives you half b. Don't take it any further than that. Well, if you try and simplify it you might make errors, like I probably would, so I'm going to leave it like that and see if RQ is exactly the same. So here's the points R and Q, and so we subtract our x values and square them, and do the same for our y values and square them. Find the square root. This is a distance formula. Now note that for the first bracket, half c minus half c conveniently disappears, and so that's going to give you a quarter a squared. When you square a negative, it disappears to become positive. Half d minus half d disappears, and so we leave it in the brackets like that. Then compare it with what we got in the previous one. So here I've put them both together, and you can see that PB is the same as QR. So therefore, they're the same length, must be parallel. Must be equal in length. And then we're going to check to see if the other two are the same length. If PR is equal to BQ, then that would make a parallelogram. Actually it would be, yes, it would be a parallelogram. So what we do there is we check for PR, we check do the same sort of things, we subtract our values and square them, and we do the same to our y values, we subtract and square them. Then what does that give us? There's our first bracket. The second bracket, 2.5 minus 2.5, that will cancel out, and so we have PR. I wouldn't take it any further than that. Do the same for BQ, and we subtract our x values and square them, subtract our y values and square them. Note that half a minus a half a comes to negative a half a squared, and same for half b minus b comes to negative half b squared. What do you notice about those two formulas? Well, they actually are the same. So PBQR will always be a parallelogram, and we've proved it.